Welcome back, Design Junkies, to Mechanical Engineering Made Simple. If you enjoy the podcast, show your support with a like, a follow, or a comment. Let's keep designing, learning, and leveling up together. Today, we are diving deep into the infrastructure that surrounds successful new product development. And we're not talking about CAD or prototyping.
No, not the hard skills.
Exactly. We're tackling the key organizational, informational, and strategic factors, the non-technical hurdles that engineers, have to navigate to get a great idea from the lab bench to an actual commercial success.
It really is the silent killer of innovation.
Yeah.
For engineers who pour all their energy into technical elegance, into optimizing a curve or improving a material property, it's just intensely frustrating when a project stalls.
Or just guys.
Or dies, yeah, because of some intangible issue.
Right.
A lack of resource commitment or, shifting political winds inside the company.
That's why our mission today is to explore those soft tools. The difference between a really exciting R&D project and a massive commercial win. It often lies entirely in the culture, the commitment, and a deep structured understanding of the customer's world.
Absolutely.
We need to figure out how successful organizations manage that messy, often overlooked starting point, the fuzzy front end of innovation.
And getting that front end right is, well, it's everything. Because if the environment isn't supportive, innovation just starves. If innovators feel that there's, no way to get the resources to validate their ideas, or if they just lack that fundamental trust in senior management support, good ideas get filed away.
And they die on the vine. So the signal that innovation matters has to be loud and clear, and it has to come from the very top. What's the specific organizational mechanism required to send that message, to establish real governance?
Senior management has to institutionalize their involvement. They need to form an innovation steering committee. And this isn't just like a quarterly check-in. This committee has to be responsible for defining the strategic direction and the financial goals for the entire innovation portfolio.
The whole thing.
The whole thing. And crucially, they must meet with the product teams at a minimum of once per month. That frequency is the signal. It tells the organization that innovation is a priority, not some side project, and that senior leaders are dedicating their scarce time to it.
That sets the precedent then. It gives the technical teams the air cover they need. But how does that committee achieve alignment when, management usually wants aggressive financial growth that R&D can't possibly deliver with the current resources?
They use a tool called portfolio rollout scenarios. These are basically modeling tools that rigorously illustrate the exact number and magnitude of products that need to be launched to hit those financial goals.
So if the CEO says, I want 20% revenue growth, the model spits out, okay, but you can't get that with 2 small product line extensions. You need 3 game changers and 5 platform updates.
Precisely. And that creates the aha moment that forces a reckoning. The scenarios show, in black and white, that the company's current budget, their risk tolerance, their resource allocation, it's all completely disconnected from their desired financial future.
So it forces that conversation.
It forces it. It
Yeah.
shows that drastic changes in process and scope and commitment are required. This is often the only way you can compel senior management to move beyond just, incrementalism.
Okay, so that strategic shift happens.
Yeah.
But how do you make sure the projects that move forward are chosen on merit, not just, based on who yells the loudest?
Yes.
How do you build that culture of rigor?
You implement standardized, explicit go-no-go criteria. These are essential because they make sure decisions are based on objective rigor and consistency. Not on politics, not personal preference, and definitely not gut sense.
Because that just demoralizes the teams.
It demoralizes them and wastes a ton of resources.
So what do these criteria need to cover? What are the big categories for that decision architecture?
They have to cover 5 non-negotiable hurdles: strategic fit, market attractiveness, customer needs, technical feasibility, and, of course, the financial hurdles.
All 5.
All 5. The key is that a project only moves forward if it clears all of them. It has to be strategically sound and financially viable and meet a real customer need. If it fails just one category, the process stops. It doesn't matter how cool the technology is.
That system sounds perfect for vetting known opportunities. But what happens when we introduce truly revolutionary tech? The radical projects where uncertainty just skyrockets. How do those criteria hold up?
They change dramatically because you're not just dealing with technical risk anymore.
Yeah.
Major innovation projects face four distinct categories of uncertainty. We always expect high levels of technical uncertainty and market uncertainty.
Right. Can we build it and will anyone buy it?
Exactly. But there are also high levels of resource uncertainty and organization uncertainty. Who's going to fund the next stage? And critically, which operating unit is going to own this high-risk project once R&D says it's done?
And this sounds like the dreaded transition management gap. So if a system like StageGate works for the small, incremental changes, where do these big, uncertain projects fall through the cracks?
They fall into a vacuum. A radical project, even when it's technically complete, still carries extremely high market and organizational uncertainty. The operating business unit, which is driven by short-term profit, by sales pressures, they can't easily absorb a project where the market is underdeveloped and the sales forecasts are, well, basically speculation.
So it's in this dangerous middle ground that nobody owns.
Nobody owns it, and so promising projects just drop off the radar.
So if you've developed a revolutionary technology but the market isn't ready for it, you can't just wait. You have to force the issue yourself. And that brings us to a really remarkable example of this, the digital micromirror device.
Right. Texas Instruments developed the DMD chip, a tiny, revolutionary semiconductor-based display for high-definition projectors. They solved these immense technical challenges, but then they just hit a wall of market uncertainty.
The projector assemblers were too nervous.
Totally risk-averse. They wouldn't commit to new designs because TI couldn't prove that sufficient end-user demand actually existed yet.
But wouldn't building the whole engine dilute TI's focus? I mean, they're a chip maker. It forces them into a whole new vertical they probably didn't want to be in.
It did, but it was a temporary tactical shift just to overcome that market barrier. TI strategically integrated forward. They temporarily changed their whole business model. Instead of just selling the chip, they built and provided the entire display engine.
The chip, the lens, the housing.
The power source, everything. They gave assemblers a complete, ready-to-use solution, and that accelerated market development and generated the demand.
And once the market was there.
Once the market was established and others saw the opportunity, TI systematically unbundled the innovation and went right back to selling just the core DMD chip. It was a calculated move designed purely to kill that market uncertainty.
That kind of strategic flexibility seems essential for radical success. But before you can even define the tech or the business model, you have to know what the customer actually needs, not just what they say they need. Which brings us to the voice of the customer dilemma.
The dilemma is that conventional market research, I'm talking surveys, simple focus groups, it usually only captures surface-level stuff, gripes, or asking customers to comment on what already exists. But developers need raw, often unarticulated, needs to drive real innovation.
The old saying, right? If you ask people what they want, they'll just ask for a faster horse.
Exactly.
So how do we use interview tactics to get past the horse and find the automobile?
Well, generally, individual one-on-one interviews are much better than group settings for getting broad and detailed needs. They let the interviewer go off on tangents, follow surprising answers without, derailing an entire focus group.
And what's the most powerful technique?
Focusing on extremes.
The best and the worst experiences.
Precisely. When you ask customers about the best and worst experiences they've ever had with a product, you get the peak moments of delight and the absolute troughs of frustration. Ask a business traveler about a hotel, they list generic things. Ask about their worst stay, they talk about a broken suitcase wheel and the Wi-Fi failing during a critical presentation.
And that's where the real needs are hiding.
That's where you get the richest, most actionable data.
But sometimes you can't rely on what the customer tells you at all. You have to rely on what they do, especially when usability problems are so common they don't even see them as problems anymore. Let's talk about the power of ethnography.
Ethnography is a highly inductive approach. It's focused entirely on context. The critical learning happens when researchers just immerse themselves. They spend time in the environment where the behavior actually takes place. You won't get statistical significance, but the insights are far more valuable for innovation.
The story of the farmer and his perfect tractor is such a great illustration of this.
Oh, absolutely. Researchers were interviewing a farmer in his kitchen, and he swore up and down his tractor was perfect, couldn't be improved. But then they walked with him out to his shed.
In context.
In context, he voluntarily revealed over 20 unique modifications he had secretly made to the equipment. Custom handles, relocated controls, added tools, all to make his workflow easier. The environment exposed all these unarticulated usability issues that the farmer had just learned to live with.
That is just gold for an engineering team.
Hmm.
And this kind of contextual awareness can also transform B2B. I mean, look at Cemex, the cement company.
They recognized that the biggest pain point for their construction customers wasn't the cement itself. It was the intense frustration and massive cost associated with bad timing. If cement arrives late, an entire crew is just standing around.
It's a perishable product.
Right. So by prioritizing rapid, reliable delivery, they reposition themselves as the Domino's pizza of cement.
Right.
They solved the core business pain, the risk and anxiety of the poor, which let them charge a huge premium.
To get to those blue sky ideas, though, you have to remove all the mental constraints of the current reality, which is the beauty of the customer idealized design, or CID, the wish mode.
The core principle is mandatory detachment. You tell participants to design their ideal product from a clean slate. You say, assume the entire current system was destroyed last night. It's a psychological trick that stops them from self-editing their ideas based on what they think is feasible.
And IKEA actually used this to build a store.
They did. Customers designing an idealized IKEA came up with an octagonal building with an open center, tons of natural light, and a restaurant oasis near the entrance, so you could eat before the long march through the maze.
All right.
The new Chicago store was based heavily on that user design, and it showed significantly higher return visits and customer satisfaction. It proved that radical user input can actually define successful business architecture.
Okay, so we have organizational commitment through the steering committee. We have a strategy informed by rollout scenarios, and we have a deep understanding of customer needs from ethnography and CID. Now, let's talk about organizing the engineering teams and how we quantify the value of their work. First up, team structure.
Right. For NPD success, creativity is maximized when teams manage a flexible balance across what we call the virtuality fingerprint. This just captures things like physical proximity, communication methods, and how structured the tasks are.
A lot of managers assume that co-location, everyone in the same room all the time, is always the best way to innovate. Why is that flawed?
Because strict, constant co-location runs a serious risk of groupthink. People start to converge on the easiest, most agreed-upon solution, and it just kills diverse perspectives.
So what do the most effective teams do?
They use co-location strategically. They get together physically for the complex, multidisciplinary decisions, like a critical design review. But then they disperse for specialized individual tasks, like detailed CAD work or component testing. This flexible approach maintains optimal creative potential.
That's a powerful insight. Finally, justifying the R&D investment. For engineers, this means translating a technical feature, like improved system uptime, into measurable, quantitative economic value for the customer.
A crucial skill. We use a structured, six-step approach that starts with pain mapping. We find the customer's business difficulty through deep interviews and then trace it back through their operational process. The goal is to get from a vague pain to an actionable metric.
Let's use that financial institution example where low system availability downtime was the pain. That's a technical spec that directly hits the bottom line.
Exactly. That technical failure, point low availability, translated directly into two massive business pains: lost sales and customer defection. So we then quantify the value of fixing that technical flaw using their own operational metrics.
Okay, so when you're calculating the value of increased sales from better uptime, how do you structure that without it sounding like a complex algebra problem?
You just map the operational flow to the money. It's a function of core variables. You look at the average number of trades per minute times the securities to a trade times the trading days per year times the average price times the difference in system availability, the old versus the new, and then times the fee rate.
So it draws a clear, undeniable line. This investment in uptime converts directly into concrete revenue. What about the longer-term value, like customer loyalty?
The value of customer loyalty is driven by three core metrics: the total number of customers, multiplied by the average lifetime value of a customer, multiplied by the customer defection rate. If you can reduce that defection rate by even a fraction of a percent by improving reliability, the value proposition for the R&D becomes massive. It can just dwarf the initial development cost.
This really shows that an engineer's technical success hinges entirely on these other tools aligning strategy, finding latent needs, and proving the economic value.
NPD success requires engineers to be organizational navigators. You have to align your tech with the strategy via steering committees. You have to understand latent needs through ethnography. You need to manage flexible teams. And you have to translate every feature into measurable, quantitative value for the customer.
That is a masterclass in the infrastructure of innovation. Before we wrap, you shared a fascinating anecdote about a project that was a technical failure in one context, but a huge success in another.
Yes, it's a powerful lesson. A team created this highly promising erasable ink for whiteboards. But during the final safety evaluation, the formulation was found to be highly toxic. For a whiteboard pen, that is a commercial failure.
And if that team was working in a silo, the project would have been killed and the investment written off.
Absolutely would have been. But because the organization required a periodic independent technology summit, a committee dedicated to reviewing existing tech, the chemical composition was reviewed by people from outside the pen division.
And they saw a different application.
The summit suggested transferring the toxic chemical formulation to the pesticide division. In that new context, the toxicity was a feature, not a bug. It quickly became a profitable component of a new product.
So the final thought for you to chew on is this. The value of your innovation is often determined not by your original design brief, but by the organizational structures that are in place to recognize its potential in a completely different context. Look beyond your immediate goal. Your next success might be a technology that someone else labeled a failure,